surface areas and volumes.
Welcome back to my YouTube channel. We were discussing the topic conversion of a solid from one shape to another. We discussed the concept and we discussed the solved problems in the textbook, and also we started exercise 13.3. We did some of those questions. In this video also we will discuss some more questions from 13.3 exercise. If you didn't watch the previous videos, you can find out those videos from the link in the description. I have given the link to the playlist of chapter number 13, surface areas and volumes, in the description. And also links to other chapters are also given there. You can check out. Now we move to next question.
Question number 7 in exercise 13.3. Question is like this. A cylindrical bucket 32 centimeter high and with a radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. Okay, so read the question very well, then draw some figures, some rough figures. It is told that a cylindrical bucket, a bucket in the shape cylinder, is full of sand. Its dimensions are given. So you can draw some figure like this. Some bucket in the shape of a cylinder. For this bucket, the height is given that 32 centimeter and the base radius is given 18 centimeter. So we can mark here 18 centimeter. And this bucket is full of sand. And this bucket is emptied on the ground and a conical heap of sand is formed. So it will look like this. Heap of sand is formed like this, like a cone. So for this cone, what is given? The height is given. Height of the conical heap is 24 centimeters. So I think better we can mark here. The height is given that 24 centimeter. We want to find the radius and the slant height of the heap. So we can mark here, this is the radius of the conical heap and this is the slant height. So how we can do this? So this is also some kind of question, almost like melting and recasting to some other shape. Here the idea is, if the cylinder have full of sand, if we empty that sand into ground, the conical heap formed will have the same volume of that of the cylinder. That's a concept. That is, the volume of the cylinder and this cone will be equal. So from the given height and radius of the cylinder, we can calculate the volume of the cylinder, and that can be substituted for the volume of the cone, and height is given. So doing some reverse step, we can calculate the radius of the cone, and then using the Pythagoras theorem, we can calculate the slant height of the cone. So we can do here. We can start by finding the volume of the cylinder. Volume of the cylinder is equal to, we have the formula pi r square h. Substitute the values. Pi, simply write pi. Maybe when we divide it will be cancelled. And r square, so radius of the cylinder is 18. So we can write 18 into 18. Then height is given that 32. So this is the volume of the cylinder. So we don't simplify for the final answer, because when we divide, it will some numbers will be cancelled. So we simply write like this. And then the volume of the cone is, we have the formula 1 by 3 pi r square h. That will be same as the volume of the cylinder. So you can substitute this volume here. So 1 by 3 pi r square h is equal to pi into 18 into 18 into 32. Okay, and here itself we can cancel pi's. Then we can substitute the given height of the cone, that is 24 centimeter. 1 by 3 into r square into h, that is 24. that is equal to 18 into 18 into 32. Here 3 in 24, 8 times, right? So this 8 we can take to right side now. So r square is equal to 18 into 18 into 32 divided by 8. So 8 and 32 can be cancelled. In 32, how many 8s? 4 8s, right? Okay. So in next step, r square is equal to 18 into 18, I write 18 square. And this 4, I think better we can write as 2 square. 2 square is 4, right? So in the next step, r square is equal to 18 square into 2 square. The square can be taken outside the bracket. So 18 into 2 all square will come. So that is r square is equal to 18 into 2 all square. That means r should be equal to 18 into 2, right? That is r is equal to 36 centimeter. So look here, I have applied some trick in solving this value of r. So otherwise what we'll have to do, we want to find the 18 square and square of 2, that is 4, and we want to multiply the square numbers, and then we want to find the square root of that number, large number. So that will take some time. So but by applying some tricks like this, we could easily find the value of r, that is 36. So this r means the base radius of the cone. Now we also want to find the slant height of the cone. So you take the right triangle inside this cone. The sides are height of the cone, base radius of the cone, and slant height. So the relation is L square is equal to h square plus r square. Substitute the given values and the value of r. So how will come? H square h is given that 24. So 24 square plus r square. We got r is equal to 36. So 36 square. So here also we can apply some tricks. Otherwise what we'll have to do is, you want to find the square of 24 and square of 36, then you want to add, then you want to find the square root of that number to get the value of L. It will take some time, so we can apply some tricks here. Look here how we can find the value of L here. Here L square is equal to 24 square plus 36 square. So 24 and 36, which is a common factor? 12 is a common factor, right? For 24 and 36, 12 is a common factor. So I split these powers as like this. 24 square we can write 12 square into 2 square, right? 12 square into 2 square is 24 square, plus 36 square I write like this, 12 square into 3 square. What is 12 square into 3 square? That is 36 all square, right? We have the rule a square into b square is equal to ab the whole square, right? Ab the whole square. So in the next step, you can write L square is equal to 12 square can be taken outside the bracket. Inside the bracket 2 square plus 3 square. So that is L square is equal to 12 square into 2 square plus 3 square, that is 4 plus 9, that is 13, right? So L will be equal to square root of, right? When we shift the square to right side, it will become square root. So square root of 12 square into 13, that is, and next step I shall write here, L is equal to square root of 12 square into square root of 13. What is square root of 12 square? It is simply 12, right? So 12 into square root of 13. You can write simply 12 root 13. This much centimeter. That should be the slant height of the cone. So we have completed the answer. I shall repeat one more time. Question was like this. There's a bucket in the shape of a cylinder which is fully filled with sand. And we empty this bucket into ground, and so a conical heap of sand is formed. So for this cylinder, the base radius and height are given. And for this cone, the height is given. And here the concept is, here the idea is, the volume will be remain unchanged when we empty full of sand in this cylinder to some figure like a conical heap, the volume of the cylinder and this heap will be same. So first we can write the volume of the cylinder. We apply the formula and substitute the values. We get like this. We don't go for simplification. Then the volume of the cone will be exactly the same. So we apply the formula of volume of the cone, that is 1 by 3 pi r square h. That will be equal to the volume of the cylinder. So we can substitute the value here. So then pi will be cancelled. Then simplifying this, we will get the radius of the cone as r is equal to 36. We also need to find the slant height of the cone. So we know the slant height and the radius of a cone makes a right triangle. So in this right triangle, applying the Pythagoras theorem, substituting the values of h and r, we can calculate the value of L, the slant height. So we got 12 root 13 centimeter.
I hope the answer is clear. If you like this video, please don't forget to press the like button and also share this video to your friends. To get more videos like this of the same chapter or other chapters of class 10 CBSE mathematics, please check in the description of this video. I have given the links to playlist of other chapters and this chapter in the description. In the next two videos, we will discuss some of very important questions from the same topic, conversion of solids from one shape to another. Until then, bye.